So sine is 75 degrees. It's not one of our special numbers like 30 or 45 or 60, but it is could be split up into this, right? So, of course, I think if you're normal, like I question sometimes, but sine of 30 plus 45, you know, the uneducated, which is kind of what you are right now in this particular topic, the uneducated would probably think you could do what with that? Distribute. And write sine of 30. I hate to even do it, but Mr. Boyd and I were talking about this the other day. He had a student in one of his classes was complaining that you always show us the wrong thing to do. You always show us the mistakes that people make, and then I do that. And he says, yeah, but when I do it, I tell you, don't do this. Right? So, but they didn't think that was good. So I'm doing that right now. I'm showing you something, and I'm going to tell you, don't do this. Right? Distributive is multiplication distributed over addition or subtraction. That's what the distributive property means. You can take multiplication distributed over addition or subtraction. Well, this is not multiplication. This is not sine times 75 degrees. That's not what this is. It's a function. Okay? So, but that's the question, right? That this could be it. All right, so let's try it. Well, what's sine of 30? That's 1/2. Right? What's sine of 45? Let's just check it on our calculator. So take 1/2 plus root 2 over 2 on your calculator. And let's see what we get. I'll just do it in my head real quick.
Oh, whoa.
Is that about right?
Oh, okay. Wait, yes.
Well, square root of 2 over 2 is 0.707, right? 1/2 split. Okay. Now, that's immediately that should tell you, well, there's no way that can be right. There's no way that sine of 75 can be 1.207. Why? Can't be more than 1. Right? Sine of anything can't be more than 1 or less than -1. Right? So there's no way that that's right. If you try it, sine of 75 degrees is point whatever, I don't know, 8, 9. What is sine of 75 degrees? Bottom line is it doesn't work. Yeah, it got to be in degree mode. It doesn't work. So all of that was bad. You cannot distribute over with sum. Okay, you can't do it. All right. So what do we do in a situation like that? Well, we use these identities right here. Okay.
Oh.
Okay. So you're right. That's a little daunting. Let's do one at a time. You will not have to memorize these. Okay. Here's the first. So now you don't have to use A and B here. I think the cheat sheet I have for you that I might either hand out or put on words uses alpha and beta, the Greek letters. The book uses U and V. It doesn't matter. You can use X plus Y. Bottom line is, you have an addition in there, sine A plus B. You can write that as sine A cosine B plus cosine A sine B. So we can talk about all kinds of ways you can memorize this, but since we're not going to memorize it, we won't bother. Okay, kind of like that soap thing you guys had with the cubes, right? You could do something similar with this, but you know we're not going to memorize it, so I wouldn't worry about it. Okay, if you want to come up with something on your own and memorize it that way, that's fine. If you put a minus sign in there, it's exactly the same, except you just put a minus sign in between. Okay. So sine A plus B is that, and sine A minus B is that. Okay. All right. If you have cosine, changes just a little bit. Cosine, so you notice with sine, it went sine and cosine, and then it flipped them and went cosine and sine. When you do cosine, the two cosines are together, and then the two sines are together, and the sign is opposite in between. Okay, so it's cosine A, cosine B, and then a minus sine A, sine B. Now make sure you copy these right. They are in your book, and you can double check. But okay, cosine A plus B. I probably should double check and make sure I get it. It was kind of early this morning when I did that. Pretty sure. Okay, and then what do you suppose with the minus?
Yeah.
It's going to be just the same, except there'll be a plus sign in between. Okay, but it's cosine A, cosine B. So it's always the A first, then the B, A, then the B. When you put them in there. So the first thing in the parentheses, second thing in parentheses. All right. So anytime we have a sum or a difference inside of there, we can do that. We're only going to worry about sine and cosine. There might be a random homework problem that has tangent. If it does, it'll only be in the homework. It won't be on the quiz. So if it is in the homework, you can look it up. Okay? It won't hurt to do it. It just, we're not going to spend time messing with it. I'm going to throw them up here, but I'm not going to give you time to even write them. Those are the tangent A plus B and the tangent A minus B. They're in your book. If you happen to need them on a random homework problem, there they would be. Okay? Something like that. All right. But we're going to mostly worry about sine and cosine. All right. So we already talked about sine of 75, right? Was not what we thought it was. So here would be 3 different ways to do sine. Now you're only going to do one of them, and I'm going to pick you at random, or not randomly, but I'm going to divide up the room here. Okay? So all 3 of those give you sine of 75 degrees, right? 120 minus 45 is 75, 135 minus 60 is 75, 30 plus 45. Okay, so you 2 rows right here, you guys do the first one. You middle rows right here, you do the middle one. You guys over here, you do the far right. Okay? Expand it out with the formulas I just gave you. And these are nice numbers, 135, 60, 120, 45. You should be able to do this without a calculator. Let's check our answer. Go ahead and put it together as a single fraction. Put it together as a fraction. Usually works out pretty nice. Fractions usually have common denominators already most of the time. When we're doing our no calculator bit with this. All right, somebody over here. We got something? Not a decimal, give me your fraction. Jeremiah, you got something? No. You can't simplify those roots that way. So back up before you did that. Root 2 is a plus root 6 over 4. Does that sound like what you guys got in the middle? Anybody get that in the middle? No?
Yes.
You got something
I got
different?
root 6 minus root 2.
You got a minus. What about you guys over here?
The 0.26.
No decimal.
It won't convert.
You don't even need to type anything into your calculator. is what I'm saying.
What?
This is no calculus.
This is no calculator. Okay. You agree with this? So you guys over on the far side of the room. Sine 30, cosine 45, plus cosine 30, sine 45, right? That's how the formula worked, right? Sine A, so double check, Jack, double check yours again here, okay? For your sines, double check your sines, okay? Sine 30, cosine 45, plus cosine 30, sine 45, okay? What's sine of 30? 1/2. What's cosine of 45? Root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 is root 2 over 2. When you multiply here, you get root 2 over 4. When you multiply here, you get root 6 over 4. You can multiply radicals. Root 3 times root 2 is root 6 over 4. Common denominators, we do this, but we can't add those together then, Jeremiah, right? Root 2 plus root 6 is just root 2 plus root 6. That's all we can do. Okay? Which is 0.95 something something. And if you do sine of 75 degrees, you will get 0.95 something something. 965 or 56? 65. 965. 0.965. Okay? Now, you guys in the middle. Shouldn't it be that right there? Sine 120, cosine 45, minus cosine 120, sine 45. But the key is, Jack, the reason that, what's cosine in the second quadrant? Negative. So negative minus a negative is going to turn to plus. That's why that ends up being a plus. Okay? So you might need to draw them. I mean, if you need to draw a 120, right, it's going to be over here with a 60-degree reference. And cosine is going to be negative 1/2. And sine of 45 is going to be root 2 over 2. Cosine of 45 is root 2 over 2. Sine of 120, second quadrant, that's going to be positive root 3 over 2. So we get root 6 plus root 2 over 4. And again, it doesn't matter if we go root 6 plus root 2 or root 2 plus root 6. So that is the same as what we got on the other side of the room. Okay? What about you guys over here? Shouldn't you be getting the same thing? We better be, right? All three of these are sine of 75 degrees, right? So we better be getting the same thing. Okay, but this is how this looks. So we're going to take that, it's going to be sine 135, cosine 60, minus cosine 135, sine 60. Same thing's going to happen right here. This cosine second quadrant is going to be negative. Okay, and it's going to be, so sine 135 is going to be a 45-degree reference over here. Okay, so that's going to be root 2 over 2. Cosine of 60 is 1/2. Cosine of 135 would be negative root 2 over 2.
It's not sine of negative.
No. Because what was the formula? The formula was A minus B. So the minus was in there, right? That's a great question. The minus was in there. Now, could you have made this plus a negative B? Now, why you'd want to make that messy, I don't know, but you could. And then use the sine plus formula, right? Because, so no, the formula is sine A minus B. Now, there's a sine A plus B that you would use on this first one, but on these I would use, so that's your A is 135, and that's your B, which is 60. Yes, not negative 60, but 60, because the minus is already there as part of the formula. Okay, good question, though. So again, minus the negative, this is going to end up being plus. Okay, so you're going to get root 2 over 4. You're going to get root 6 over 4. You're going to get positive, right? So you're going to get that answer. So that's how these formulas are going to work. Okay? All right. So now, here's a question. How can we do cosine of 7 pi 12? So on your homework, the first part of your homework today, they're going to give you some angles like I just did with 75. And then they're going to tell you that they want you to do 75 is 30 plus 45. Or they want you to do 75 as 135 minus 60. They're going to tell you what they want you to do. Then you're going to have some where you get to decide. Okay? So 7 pi 12ths is not one that we know about. What would add up or subtract to 7 pi 12ths?
In degrees or something?
Well, if it's in radians, we want to stay in radians. If it's in degrees, we want to stay in degrees. If it's radians, we want to stay in radians. Okay, so what I would look for, now, of course, you want them to be ones that are nice numbers, but you can just think about it, because, yeah, we could go 2 pi 12ths and 5 pi 12ths, but 5 pi 12ths is awful. That's not one we like. So you would say, I don't want to do that. Or you could do 1 pi 12 plus 6 pi 12ths, but 1 pi 12ths is no good, right? But 3 pi 12ths would be pi 4ths, and 4 pi 12ths would be pi thirds. Now, what else can I do? How about 15 pi 12ths minus 8 pi 12ths? Aren't those both nice ones? That's going to be 5 pi thirds? No. Fourths? That's going to be 5 pi fourths, and that's going to be 2 pi thirds. Right? So those won't be bad. So you'll have options, but I would say you'd stick with the simplest ones. Probably try to add if you could. Now, if this was 1 pi 12th, you're not going to be able to add. You're going to have to subtract. So if it's a real small number, you probably have to subtract. If it's a little bigger, you can maybe have a choice. Okay, so everybody do it. Let's do it real quick. So let's break this into this. Okay, which order you do them doesn't really matter. You could do pi thirds first and the pi fourths second. It's not going to matter. Okay, everybody try that one. Okay, I've got a few of the steps up here if you want to look, check, see where you're at. Now again, if you would have written it pi thirds and then pi fourths, it doesn't matter. Your numbers these would just be switched around and these would be switched around, but again, it'll be fine because it doesn't matter with plus what order we have them, and that's why it actually works out well with the cosine one, since both cosines are here, right? It doesn't matter. You times them, it doesn't matter what order you times it, and the signs are after, okay? And then on the plus one with sine, since we do a sine, then a cosine, and then we plus, and then we switch a sine and cosine, again, the order doesn't matter there either. So we'd expect that to work okay. Okay, so again, we see some of these common numbers that you'll often see, the root 2 and the root 6, because we're going to be using some of these same numbers. Okay, now that would actually be negative. If you did convert that to a decimal, that'd be negative, which makes sense because 7 pi 12ths is in quadrant 2. Right? 7 pi 12ths is in quadrant 2. So cosine in quadrant 2 should be negative. Right? But we can just leave it, we'll just leave it just like that if we're doing this as a no calculator, which is where we would be doing this problem like this. Okay? So, going to give you some of those that can easily be turned into some of our nice 30, 45, 60, or pi 6, pi thirds, pi fours kind of numbers. Okay? All right. So, I just reworked it, except I did a subtraction. I did 9 pi 12ths, take away 2 pi 12ths, which is 3 pi fourths and pi 6, and did it as a minus. And you can see we came out with the same thing. It was negative 6 plus root 2, which is the same as root 2 take away root 6, but it came out exactly the same. Okay? All right. So, here would be where you could use this in an identity. Okay? In an identity. Now, we know that sine of pi halves minus x equals cosine x is one of our warm-up problems today. Right? We know that that's true. But if I wanted to say prove that it's true, right, we now have a way of doing that. We didn't before. This was just an identity we memorized. We just knew sine of pi halves minus x is equal to cosine x. Those co-functions, okay, complementary. But now we could, right? We could just take the left side and do that with it. Pi halves would be our A, and x would be the B. And we could do the formula for sine with a minus. Was, if you remember, sine of the first one, cosine of the second one. It was sine A, cosine B. Then it was minus, then it was cosine A, sine B. Okay, but again, you're going to have that laid in front of you, that identity, so you're not going to have to memorize it. Okay, you just need to put your A in, put your B in. Okay, well, what's sine of pi halves? 1. What's cosine of pi halves? 0. So you would have 1 times cosine minus 0 times sine is just cosine. And so we just proved that that identity does work, right, using that difference identity. Okay? All right? Another identity we have, another identity we've talked about is this one, because it's an even function. So if you put cosine of negative x, that's the same as cosine of x, right? Now, sine negative x is negative sine x, right? Where you pull the negative out. With cosine, the negative just goes away. And again, that's not something we would prove. We just knew that that was true, and we could substitute one for the other. Well, now we could actually prove it. Okay, we could change cosine negative x into cosine 0 minus x, because that's another way to write negative x. Right? So we could write that cosine 0 minus x, and now apply our cosine rule. What's the cosine rule? Cosine A, cosine B, plus sine A, sine B. Cosine A, cosine B, plus sine A, sine B. Okay, well, what's cosine of 0? No? Cosine of 0 is 1. Sine of 0, 0. So we get 1 times cosine plus 0 times sine, which wipes that out. We just get cosine. Okay, so just a couple of other uses, a couple other places we could use this sum or difference identity. Okay, all right, last thing we're going to do with it, we probably will not finish it up here, but so the last type of problem I have, find sine of u plus b if sine, so you would be given all this in the problem. Find sine of u plus b if sine of u is 4/5 in quadrant 1, because remember, sine of 4/5, if sine is equal to 4/5, that could be in quadrant 1 or 2, right? Sine's positive in 1 or 2. So, or you might be given it this way. You might be given it, they might say that u is, use the angle, right? They might say u is between 0 and pi halves. So they're telling you it's in quadrant 1. Okay? And cosine of V is negative 12/13. Now we don't, those aren't special values that we know what those angles would be. And they say quadrant 3. Or they might have said V is in, V is between pi and 3 pi halves. Okay? So what would you do with this information if you were told that sine is 4/5 in quadrant 1? What would you draw? When you draw a triangle, and you'd put 4 opposite, 5 there, which of course would mean 3 would be there. And if you're not sure, do the Pythagorean theorem. Okay? So we're not going to find what u is, but we can find what cosine of u is, right? Cosine of u would be 3/5. And then we're going to do the same thing in the other one. Now we're supposed to find sine u plus v. All right? What's sine of u plus v? Well, sine of u plus v is our new identity, right? So to find that answer, we need sine u, which we're given. We need cosine v, which we're given. We need cosine u, which we can get from the triangle. And we need sine v, which we can get from that triangle that we'll draw when we get back. And then we'll have our fractions, and then we can just multiply them together. Okay? So given some information where we can draw some triangles. Okay, so that's how we can do these problems where we don't know that if they're not pi 6, pi 3rd, pi 4th. Or 1 over root 3, right? If it's not one of those special fractions that we should by now always recognize, that's one of our, nice angles. If it's some fraction like this, almost always then that's draw a triangle. Draw a triangle. So sine in quadrant 1, sine is 4/5, so that's going to be this. Okay, quadrant 3, draw a triangle. Cosine is negative 12/13. So what's the other number that goes with that? It's 5, right? So it's nice to know some of your Pythagorean triples. 3, 4, 5, 5, 12, 13. Those are good ones to know. 6, 8, 10. There's some other ones, right? But 6, 8, 10 would just reduce to this, actually. But those are probably the ones you get most often. If they're not a nice Pythagorean triple, you might have a square root, right? You might have a square root 12 or something. And I'm okay if you leave it square root 12. You don't have to simplify that into 2 root 3 or anything like that. Okay? If you would get a square root one. Okay, so that now we just have to plug those in, right? So now we just have to plug those in. So sine of u. So the idea is this would be u. Okay, so once we draw that picture, that's our u, and then here's our v. Around v's not this little angle here. Remember, v's this whole angle. V would be that whole angle there. But the idea is sine of u would be 4/5. Cosine of v would be -12/13. Just make sure you go to the right triangle, right? You go to the right triangle for your numbers. That's probably where the most common mistake is made, okay? Or maybe not putting the right sign on it, like you might not put a negative on that 5 down there. See, we could have been in quadrant 2 with this one. Cosine is negative in 2 and 3, so that's why you had to be told which one to go in, okay? And so cosine of u would be 3/5. Sine of v would be -5/13. And then, again, we almost always will have common denominators here, especially when we stick with sines and cosines, okay? And so we don't have to really worry about getting those too much. And then we get this value here, which is less than 1, which we'd expect. You're finding the sign of something, so you should get a number between -1 and 1. And it happens to be negative this time. Okay, so problem like that, should be able to do that. Okay, what happens if you see a secant? I'm just going to make a comment about it. What happens if you see a secant or a cosecant of m minus n or a minus b or u minus v, whatever, those letters don't matter. Okay, what if you saw a secant? Well, remember, that's 1 over cosine. So that would just be 1 over cosine m, cosine n, plus sine m, sine n, right? So you might as well just pretend it was cosine, get your answer, and then just flip it, right? Because that's what it is. It's just, secant would be 1 over cosine, so all that would be on the bottom. So you might as well just do all that, and then just flip it, okay? So if you see secant or cosine, do sine or cosine, whichever one it goes with, and then just flip it. Okay. All right, and like I said, if you see a tangent one, then look it up and you can do it. But I don't think there's any of those. We're going to skip those. Okay, so here's homework. So again, on 13 through 27 odd, right? Those are the ones that you have to do 2 for each one. But so there's about 6 or 7 of those, but skip tangent. Don't do tangent, right? So do the sine, do the cosine of it. All right, got the rest of the time to work.